beneath the restless surface of the world's oceans, where sunlight fades into a blue oblivion, and the weight of water presses with unimaginable force, there exists a realm so alien, so mysterious, that it challenges everything we think we know about life on Earth. This is not the world of coral reefs and playful dolphins, nor the familiar territory of whales and sharks. This is the abyss, a place where the rules of biology, physics, and even time itself seem to bend and break. Here, in the crushing darkness, life has found a way not just to survive, but to thrive in forms so bizarre, so improbable, that they seem to defy the very logic of existence. Are we truly alone in the universe? Or do the answers to that question lie not in the stars above, but in the uncharted depths below? Imagine descending in a submersible, the lights of the surface world fading behind you, replaced by a darkness so complete it feels like a physical presence. The temperature drops, the pressure mounts, and the silence becomes absolute, broken only by the hum of your vessel and the distant, almost imperceptible sounds of the deep. As you sink past the last rays of sunlight, you enter the twilight zone, a region where the familiar gives way to the unknown. Here the water is cold, the pressure is crushing, and yet against all odds life persists. But this is only the beginning. Deeper still, beyond the reach of even the most intrepid divers, lies the midnight zone, a world so hostile that for centuries scientists believed it to be lifeless. And yet, as technology has advanced and our curiosity has driven us ever deeper, we have discovered creatures that seem to have stepped out of a fever dream. Transparent predators with jaws that unhinge like a snake's, fish that generate their own light in the pitch-black void, and organisms that feed not on sunlight, but on the chemical energy of the earth itself. These are the denizens of the deep, the living proof that life is not only stranger than we imagine, but stranger than we can imagine. What does it mean to exist in a place where the sun never shines, where the pressure would crush a human in an instant, and where food is so scarce that every meal is a matter of life and death? How do these creatures find each other, communicate, reproduce, and hunt in a world without light or warmth? And perhaps most tantalizing of all, what secrets do they hold about the origins of life on Earth and the possibility of life elsewhere in the universe? In this journey, we will descend into the abyss, exploring the most extreme environments on our planet and meeting the creatures that call them home. We will uncover the stories of discovery that have rewritten the textbooks, the scientific mysteries that remain unsolved, and the philosophical questions that haunt every explorer who has ever gazed into the deep. Along the way, we will confront the limits of our own understanding and perhaps glimpse the answer to the question that has haunted humanity for millennia. Are we alone? But before we can answer that, we must first understand what it means to be alive in the deep. The ocean covers more than 70% of our planet, and yet, we have explored less than 5% of its depths. The vast majority of the ocean remains a blank space on our maps, a frontier as unexplored as the surface of Mars. In these uncharted waters, life has evolved along paths so divergent from our own that it is almost unrecognizable. Some creatures have adapted to the crushing pressure by developing flexible, gelatinous bodies. Others have evolved to generate their own light, using bioluminescence to attract prey, communicate, or camouflage themselves in the darkness. Still others have developed symbiotic relationships with bacteria, feeding not on plants or animals, but on the chemical energy released by hydrothermal vents. The diversity of life in the deep sea is staggering. In the Mariana Trench, the deepest point on Earth, scientists have discovered amphipods, tiny shrimp-like creatures that can withstand pressures more than 1,000 times greater than at sea level. In the pitch-black waters of the mid-Atlantic ridge, giant tube worms cluster around hydrothermal vents, their bodies nourished by bacteria that convert toxic chemicals into food. In the Gulf of Mexico, the vampire squid drifts through the darkness, its webbed arms trailing behind it like a cloak, its body glowing with an eerie, otherworldly light. Each of these creatures is a testament to the power of evolution, a reminder that life is not limited by the boundaries of our imagination. But they are also a challenge to our understanding of what is possible, and a challenge to our assumptions about where life can exist. If life can thrive in the most extreme environments on Earth, what does that say about the possibility of life elsewhere in the universe? Could there be creatures even stranger than those of the deep, living beneath the icy crust of Europa, or in the methane lakes of Titan? As we begin our descent into the abyss, let us keep these questions in mind. For in the darkness below we may find not only the answers to the mysteries of our own planet, but clues to the greatest mystery of all. Are we alone? The journey is just beginning. In the next section, we will explore the history of deep-sea exploration, from the earliest myths and legends to the cutting-edge technology that allows us to peer into the unknown. We will meet the pioneers who risked everything to venture into the deep and discover how their discoveries have changed our understanding of life itself. But as we will see, every answer only leads to more questions, and the greatest mysteries still lie ahead.
Long before the first submersible ever slipped beneath the waves, the deep sea was a place of myth and terror. Ancient mariners gazed out over the endless blue and imagined monsters lurking in the darkness below. Krakens with tentacles long enough to drag ships to the bottom, leviathans that could swallow a manhole, and ghostly apparitions that haunted the dreams of sailors. The ocean's depths were a blank canvas for the human imagination, a realm where the rules of the surface world no longer applied. For centuries, the deep was a place to be feared, not explored. Yet even in the age of myth, there were those who wondered what lay beneath. The Greeks told stories of the god Poseidon ruling over a kingdom of strange and wondrous creatures. The Norse believed that the world serpent Jörmungandr circled the earth beneath the sea. In every culture, the ocean was a place of both danger and possibility, a boundary between the known and the unknown. It wasn't until the 19th century that humanity began to pierce the veil of the deep with science rather than superstition. In 1872, the HMS Challenger set sail from England on a voyage that would change the world. Over the course of 4 years, the Challenger's crew crisscrossed the globe, taking soundings, collecting samples, and dredging the ocean floor. What they found was astonishing, a world teeming with life even at depths where no sunlight could reach. The Challenger expedition discovered more than 4,000 new species, from delicate glass sponges to bizarre blind fish. The deep, it seemed, was not a lifeless void, but a vibrant ecosystem unlike anything on land. The Challenger's discoveries were just the beginning. In the decades that followed, scientists developed new tools and techniques for exploring the ocean's depths. The invention of the bathyscaphe, a deep-diving submersible, allowed humans to descend thousands of meters below the surface for the first time. In 1960, Jacques Piccard and Don Walsh made history by reaching the bottom of the Mariana Trench, nearly 11,000 meters down. For 20 minutes they sat in the darkness, peering out at a landscape that no human had ever seen. To their amazement, they spotted a flatfish swimming across the seafloor, a living creature in a place where, by all logic, life should not exist. With each new expedition, the boundaries of the possible were pushed further. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, now allow scientists to explore the deep for days or even weeks at a time, capturing high-definition video and collecting samples from places no human could survive. These machines have revealed a world of staggering diversity and complexity. Forests of tube worms clustered around hydrothermal vents, swarms of shrimp feeding on chemical plumes, and jellyfish that pulse with their own internal light. But for all our technological advances, the deep remains a place of mystery. More than 80% of the ocean is still unexplored, its secrets hidden beneath miles of water. Every expedition brings new surprises, creatures that defy classification, ecosystems that operate on principles we barely understand, and geological features that rewrite our understanding of the planet itself. The history of deep-sea exploration is a story of both triumph and humility. For every discovery, there are 100 questions left unanswered. Why do some deep-sea creatures glow with bioluminescence? How do they find food in a world where resources are scarce? What drives the incredible diversity of life in the abyss, and how did it evolve in such isolation? These are not just scientific questions, they are philosophical ones, touching on the very nature of life and our place in the universe. As we look back on the history of exploration, it's clear that the deep sea is not just a frontier of science, but a frontier of the imagination. The creatures we have found there are stranger than any myth, living proof that the universe is more complex, more beautiful, and more mysterious than we can comprehend. And yet, for all we have learned, we have only scratched the surface. In the next section, we will begin our descent into the abyss in earnest, exploring the different zones of the deep ocean and the unique challenges they present. We will discover how life has adapted to the crushing pressures, freezing temperatures, and eternal darkness of the deep, and meet some of the most extraordinary creatures ever discovered, from the twilight zone to the Hadal depths. Each layer of the ocean is a world unto itself, filled with wonders that challenge our understanding of what it means to be alive. But as we will see, the deeper we go, the stranger things become. The creatures of the deep are not just survivors, they are pioneers, pushing the boundaries of biology and redefining the limits of possibility. In their world, nothing is as it seems, and every discovery raises new questions. What secrets do they hold about the origins of life on Earth? And what might they teach us about the possibility of life beyond our planet? The journey continues and the mysteries only deepen. As we prepare to enter the twilight zone, let us remember that the ocean is not just a place, it is a story, written in the language of evolution, adaptation, and survival. And in that story, we are only just beginning to turn the first page. The descent into the deep ocean is not a single plunge, but a journey through a series of distinct and increasingly alien worlds. Each layer or zone presents its own challenges and has shaped the evolution of its inhabitants in remarkable ways. As we leave the sunlit surface behind, we first enter the mesopelagic, or twilight zone, a region that stretches from about 200 to 1,000 meters below the surface. Here the last traces of sunlight fade into a perpetual dusk, and the world takes on a ghostly blue hue. It is a place of transition, where the familiar gives way to the unknown. In the twilight zone, life is a delicate balancing act. The faint light that filters down from above is just enough to create shadows, but not enough to support photosynthesis. Most of the creatures here are masters of camouflage, blending into the dim background to avoid predators. Many have large, sensitive eyes adapted to the low light, and some can even see wavelengths of light that are invisible to humans. The lanternfish, for example, is one of the most abundant vertebrates on the planet, and its body is studded with photophores, tiny organs that produce light. By adjusting the brightness and pattern of these lights, lanternfish can disappear into the background, confusing both predators and prey. But the twilight zone is not just a place of hiding. It is also a place of hunting. Many of the animals here are migrators, rising toward the surface at night to feed and retreating to the safety of the depths by day. This nightly migration, known as the Deal vertical migration, is the largest movement of biomass on Earth, involving billions of creatures from tiny zooplankton to massive squid. It is a dance of survival, driven by the need to find food while avoiding becoming food themselves. As we descend further, the light fades completely, and we enter the bathypelagic or midnight zone. Here at depths of 1,000 to 4,000 meters, the darkness is absolute. The pressure is immense, hundreds of times greater than at the surface, and the temperature hovers just above freezing. In this world without light, life has taken on forms that seem to belong to another planet. One of the most striking adaptations in the midnight zone is bioluminescence. the ability to produce light through chemical reactions within the body. In the absence of sunlight, bioluminescence becomes a tool for survival, used for everything from attracting prey to communicating with potential mates. The anglerfish, perhaps the most iconic denizen of the deep, dangles a glowing lure in front of its mouth, enticing smaller fish to come closer before snapping them up in its cavernous jaws. Other creatures like the hatchetfish use bioluminescence to create a counter-illumination effect, matching the faint light from above to render themselves invisible to predators lurking below. The diversity of life in the midnight zone is astonishing. There are gulper eels with jaws that can engulf prey half their size, vampire squids that drift through the water with webbed arms and glowing eyes, and deep-sea jellyfish that pulse with shifting colors. Many of these creatures are soft-bodied and gelatinous, adaptations that allow them to withstand the crushing pressure of the deep. Others have evolved slow metabolisms, enabling them to survive on the meager scraps of food that drift down from above. But even the midnight zone is not the end of the journey. Below 4,000 meters lies the abyssopelagic or abyssal zone, a region so vast and so empty that it is sometimes called the desert of the deep. Here, the seafloor stretches for thousands of kilometers, broken only by the occasional seamount or trench. The pressure is nearly unfathomable, and the temperature is just a few degrees above freezing. Yet even here life persists. Giant amphipods scavenge the seafloor, brittle stars crawl across the mud, and sea cucumbers filter organic particles from the water. And then, at the very bottom, we reach the Hadal Zone, the deepest part of the ocean, found in the trenches that scar the seafloor. The Mariana Trench, the deepest of them all, plunges nearly 11,000 meters below the surface. In this world of perpetual night, the pressure is more than 1,000 times greater than at sea level, and the environment is so extreme that it was once thought to be completely lifeless. But recent explorations have revealed a surprising abundance of life. Amphipods, giant single-celled organisms called xenophyophories, and even fish that glide through the darkness with ghostly grace. Each of these zones is a world unto itself, shaped by the relentless forces of pressure, temperature, and darkness. The creatures that inhabit them are not just survivors, they are the ultimate pioneers, living proof that life can adapt to even the most inhospitable environments. Their existence challenges our assumptions about where life can exist and how it can evolve in isolation. But for all we have learned about the zones of the deep, there is still so much we do not know. What drives the incredible diversity of life in these extreme environments? How do these creatures find food, reproduce, and communicate in a world without light? And what secrets do they hold about the origins of life on Earth and the possibility of life elsewhere in the universe? In the next section, we will begin to meet some of the most extraordinary creatures of the deep, exploring their unique adaptations and the mysteries they present. From the glowing predators of the midnight zone to the ancient survivors of the abyss, each has a story to tell, a story that may hold the key. As we venture deeper into the ocean's shadowy realms, the creatures we encounter become ever more astonishing, living paradoxes that seem to defy the very rules of biology. Each one is a marvel of adaptation, a testament to the relentless creativity of evolution. In the midnight zone, where darkness reigns and the pressure is crushing, life has taken on forms so bizarre that they seem to belong to another world. Here survival is a game of innovation, and the stakes could not be higher. Consider the anglerfish, a creature whose grotesque appearance has made it an icon of the deep, with its enormous mouth, needle-sharp teeth, and a bioluminescent lure that dangles from its forehead. The anglerfish is both hunter and trap. In the pitch-black void it becomes invisible, save for the eerie glow of its lure. Smaller fish, drawn by the promise of an easy meal, approach, only to be swallowed whole in a sudden violent snap. But the anglerfish's adaptations go even further. In some species, the males are tiny compared to the females, living as little more than parasites, fusing their bodies to their mates and providing sperm in exchange for nutrients. It is a strategy born of desperation, a way to ensure reproduction in a world where encounters with others of your kind are vanishingly rare. The gulper eel is another denizen of the deep that seems to have been conjured from a fever dream. Its most striking feature is its enormous hinged mouth, which can open wide enough to engulf prey half its own size. The gulper eel's body is long and ribbon-like, allowing it to move with a sinuous grace through the water. Its tail ends in a bioluminescent organ, which it uses to attract prey in the darkness. When food is scarce, the gulper eel can go for long periods without eating, slowing its metabolism to a crawl. It is a master of patience, waiting in the darkness for the perfect moment to strike. Then there is the vampire squid, a creature whose name alone conjures images of horror and mystery. Despite its fearsome moniker, the vampire squid is a gentle scavenger, drifting through the water with its webbed arms trailing behind it like a cloak. Its body is covered in light-producing organs, which it can flash in dazzling displays to confuse predators. When threatened, the vampire squid can turn itself inside out, enveloping its body in its own arms and creating a writhing, glowing mass that is nearly impossible to grasp. It feeds on marine snow, a constant rain of organic debris that drifts down from the surface, providing a lifeline for countless creatures in the deep. Bioluminescence is perhaps the most remarkable adaptation of all. In the absence of sunlight, many deep-sea creatures have evolved the ability to produce their own light, using it for everything from hunting to communication to camouflage. The hatchetfish, for example, has a body lined with photophores that emit a soft blue glow. By adjusting the intensity of this light, the hatchetfish can match the faint illumination from above, rendering itself nearly invisible to predators lurking below. Other creatures, like the comb jelly, use bioluminescence to create mesmerizing displays of color, pulsing with shifting rainbows as they drift through the water. But not all adaptations are about light. In the crushing darkness of the deep, some creatures have evolved to do without eyes altogether. The deep-sea tripod fish, for instance, relies on long, sensitive fins to detect vibrations in the water, allowing it to feel its way through the darkness. Others, like the giant amphipod, have developed tough, flexible bodies that can withstand the immense pressure of the abyss. Still others, like the deep-sea snailfish, have antifreeze proteins in their blood, preventing their tissues from freezing in the near-icy temperatures. The diversity of life in the deep is matched only by the ingenuity of its adaptations. Each creature is a solution to a unique set of challenges, a living experiment in the possibilities of existence. Some, like the giant tube worms found around hydrothermal vents, have formed symbiotic relationships with bacteria, allowing them to thrive in environments that would be toxic to most other forms of life. These tube worms have no mouths or digestive systems. Instead, they rely on their bacterial partners to convert the chemicals spewing from the vents into energy. It is a partnership that has allowed them to colonize some of the most extreme environments on Earth. The more we learn about these creatures, the more we realize how little we truly understand. How did such complex adaptations evolve in the isolation of the deep? What genetic and biochemical tricks have allowed these organisms to survive where others cannot? And what does their existence tell us about the potential for life in other extreme environments on Earth and beyond? As we continue our journey, we will delve deeper into the mysteries of the deep sea, exploring the ecosystems that have formed around hydrothermal vents, cold seeps, and other geological features. We will meet the scientists who are unraveling the secrets of these hidden worlds, and discover how their work is reshaping our understanding of life itself. But for every answer, there are new questions, new mysteries waiting to be uncovered in the darkness below. The story of the deep sea is far from over. In the next section, we will explore the strange and wonderful communities that thrive around hydrothermal vents, oases of life in an otherwise barren landscape. Here in the heart of the abyss, we may find clues not only to the origins of life on Earth, but to the possibility of life elsewhere in the universe. The journey continues and the questions only grow more profound. In the vast emptiness of the abyssal plain, where the seafloor stretches for thousands of kilometers in every direction, and the darkness is unbroken. There exist islands of life so vibrant and unexpected that they have revolutionized our understanding of biology. These are the hydrothermal vents, cracks in the Earth's crust where superheated mineral-rich water gushes into the ocean, creating a chemical oasis in an otherwise barren world. Discovered only in the late 1970s, hydrothermal vents have become one of the most important frontiers in the search for life's origins and the limits of habitability. The story of hydrothermal vents begins with the restless geology of the ocean floor. Along the mid-ocean ridges, tectonic plates are constantly pulling apart, allowing magma to rise and create new crust. In some places, seawater seeps down through cracks in the rock, is heated by the underlying magma, and then erupts back into the ocean at temperatures that can exceed 400 degrees Celsius. The result is a plume of hot, mineral-laden water that billows up from the seafloor, creating towering chimneys of black smoke and a landscape unlike anything else on Earth. For decades, scientists believed that life in the deep ocean depended entirely on the rain of organic material from the surface, the so-called marine snow. But the discovery of hydrothermal vents shattered that assumption. Around these vents, researchers found dense communities of organisms thriving in complete darkness, cut off from the sun and the photosynthetic food web. Instead of relying on sunlight, these creatures depend on chemosynthesis, a process in which bacteria convert the chemicals in the vent water, such as hydrogen sulfide, into energy. At the heart of these vent communities are the giant tube worms, Riftia peshiptila, which can grow over 2 meters long. These remarkable animals have no mouths, no stomachs, and no digestive tracts. Instead, their bodies are filled with symbiotic bacteria that perform chemosynthesis, providing all the nutrients the worms need to survive. The tube worms' bright red plumes are rich in hemoglobin, allowing them to absorb both oxygen and hydrogen sulfide from the water and deliver it to their bacterial partners. It is a relationship so intimate that the boundaries between animal and microbe blur, creating a new kind of organism, a living partnership forged in the crucible of the deep. But tube worms are only the beginning. Around hydrothermal vents, scientists have discovered a dizzying array of life. Giant clams with iridescent shells, blind shrimp that navigate by sensing heat, and crabs with hairy pincers that farm bacteria on their bodies. Each species is exquisitely adapted to the unique conditions of the vent environment, from the scalding temperatures to the toxic chemicals that would kill most other forms of life. Some vents are so hot that only a thin layer of cool water separates the animals from instant death, while others are surrounded by fields of shimmering minerals and strange, crystalline formations. The discovery of these vent communities has profound implications for our understanding of life's origins. On the early Earth, before the rise of oxygen and the development of photosynthesis, hydrothermal vents may have provided the perfect environment for the first living cells to emerge. The combination of heat, minerals, and chemical gradients could have driven the formation of complex organic molecules, setting the stage for the evolution of life as we know it. Even today, some scientists believe that the descendants of these ancient microbes still inhabit the vents, living fossils that connect us to the dawn of life on our planet. But the significance of hydrothermal vents goes beyond Earth. In recent years, the search for life beyond our planet has focused on places like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both of which are believed to have subsurface oceans heated by tidal forces. If hydrothermal vents can support life in the crushing darkness of Earth's deep sea, could similar environments exist on these distant worlds? Could alien tube worms and chemosynthetic bacteria be thriving beneath the icy crusts of other planets, waiting to be discovered by future explorers? The questions raised by hydrothermal vents are as profound as they are exciting. How do these communities form and persist in such extreme conditions? What new forms of life remain to be discovered in the unexplored reaches of the deep? And what can these creatures teach us about the resilience and adaptability of life itself? As we leave the hydrothermal vents behind, our journey through the deep sea is far from over. In the next section, we will explore another kind of oasis in the abyss, the cold seeps where methane and other hydrocarbons bubble up from the seafloor, creating yet another unique ecosystem. Here too, life has found a way to thrive in the darkness, forging new partnerships and evolving new strategies for survival. The deep sea is a world of endless possibility, and with every discovery, the boundaries of the possible are pushed ever further. The adventure continues, and the mysteries only deepen. What other secrets lie hidden in the darkness waiting to be uncovered? The answers may change not only our understanding of the ocean, but our place in the universe itself. Beyond the volcanic heat and mineral plumes of hydrothermal vents, the deep sea offers yet another paradox. Cold seeps, places where life flourishes not in the presence of fire, but in the slow, silent exhalation of the earth itself. Cold seeps are regions on the ocean floor where hydrocarbons, primarily methane and hydrogen sulfide, leak from beneath the seabed, creating chemical-rich oases in the otherwise barren abyss. Unlike the dramatic towering chimneys of hydrothermal vents, cold seeps are often subtle, marked by gentle mounds, shimmering pools, and carpets of strange, ghostly life. At first glance, a cold seep might seem unremarkable, a patch of seafloor where bubbles rise slowly from the mud, or where the water shimmers with the faintest hint of oil. But look closer, and you'll find a thriving community of organisms, each one perfectly adapted to this unique environment. Here, as at the vents, the foundation of the ecosystem is chemosynthesis. Bacteria and archaea, invisible to the naked eye, consume the methane and hydrogen sulfide, converting these chemicals into energy. These microbes form dense mats on the seafloor, providing food for a host of larger creatures. One of the most iconic inhabitants of cold seeps is the mussel. These deep-sea mussels are giants compared to their shallow water relatives, and they owe their size and success to a remarkable partnership with chemosynthetic bacteria. Inside their gills, the mussels harbor colonies of microbes that process the seep's chemicals, providing the mussels with a steady supply of nutrients. This symbiosis allows the mussels to thrive in places where there is little or no other food, forming dense beds that can stretch for hundreds of meters across the seafloor. Nearby, tube worms, distant cousins of those found at hydrothermal vents, anchor themselves in the mud, their long, slender bodies reaching up toward the water. Like their vent-dwelling relatives, these tube worms have no mouths or digestive systems. Instead, they rely entirely on their internal bacteria to convert the seep's chemicals into energy. Some species can live for centuries, growing slowly in the cold, stable environment of the seep. But the community does not end there. Clams, crabs, and shrimp graze on the bacterial mats, while predatory fish and octopuses patrol the edges, hunting for an easy meal. Some of the most bizarre creatures in the deep sea are found at cold seeps, including the enigmatic ice worms that burrow into methane hydrate, solid, ice-like deposits of methane and water that form under the immense pressure of the deep. These worms feed on the bacteria that colonize the hydrate, carving out a living in one of the most inhospitable environments on Earth. Cold seeps are not static. They are dynamic, ever-changing landscapes. Over time, the flow of chemicals can shift, causing old seeps to die out and new ones to form. As the chemistry of the seep changes, so too does the community of organisms that depends on it. Some seeps are short-lived, lasting only a few years, while others persist for centuries, supporting generations of deep-sea life. The discovery of cold seeps has expanded our understanding of the deep sea's complexity and resilience. These ecosystems demonstrate that life can adapt not only to the presence of heat and minerals, as at hydrothermal vents, but also to the slow, cold seepage of chemicals from the Earth's crust. They are a testament to the versatility of chemosynthesis, and a reminder that the deep sea is a world of endless innovation. But cold seeps are more than just biological curiosities. They are also windows into the Earth's geology and climate. The methane that bubbles up from the seafloor is a powerful greenhouse gas, and the processes that control its release and consumption have implications for the planet's climate. Some scientists believe that massive releases of methane from the seafloor may have played a role in past climate events. And understanding how cold seep communities process this gas could be crucial for predicting future changes. As we explore the cold seeps, we are reminded once again of the deep sea's capacity for surprise. In a world where sunlight never penetrates, where the pressure is crushing and the temperature hovers just above freezing, life has found a way, not just to survive, but to flourish. The creatures of the cold seeps are living proof that the boundaries of the possible are far wider than we once imagined. Yet for all we have learned, the cold seeps remain a frontier. New species are discovered with every expedition, and many of the fundamental questions about these ecosystems remain unanswered. How do the microbes that power the seeps evolve and adapt to changing conditions? What unknown creatures might be lurking in the unexplored seeps of the world's oceans? And what can these communities teach us about the potential for life in other cold, dark places on Earth and beyond? In the next section, we will turn our attention to the deep sea trenches, the Hadal zones that represent the ultimate frontier of exploration. Here, in the deepest places on Earth, life persists against all odds, challenging our understanding of biology and the limits of survival. The journey into the abyss continues, and with every step the question grows more urgent. Are we truly alone, or are the answers to that question waiting for us in the darkness below? The deep-sea trenches, known as the Hadal zones, are the most extreme and least explored environments on our planet. These narrow, plunging chasms cut deep into the ocean floor, reaching depths of more than 11,000 meters, far deeper than Mount Everest is tall. The Mariana Trench, the Kermadec Trench, the Tonga Trench, and others form a hidden network of valleys and gorges that are almost entirely inaccessible to humans. For decades, these places were thought to be lifeless, too cold, too dark, and too pressurized for any organism to survive. Yet, as our technology has advanced, we have discovered that even here, in the planet's deepest shadows, life not only exists, it thrives. Descending into a trench is like entering another world. The pressure increases by 1 atmosphere every 10 meters, so at the bottom of the Mariana Trench, the pressure is over 1,000 times greater than at the surface. The temperature hovers just above freezing, and the darkness is absolute. No sunlight has ever reached these depths. The water is so dense and heavy that it seems to press in from all sides, and the silence is profound, broken only by the occasional rumble of an earthquake or the distant echo of a landslide. Yet, in this alien environment, life has found a way. The first clues came from the Challenger Deep, the lowest point in the Mariana Trench. When the bathyscaphe Trieste made its historic descent in 1960, the crew reported seeing a flatfish swimming across the seafloor, a sight that stunned scientists and challenged the prevailing belief that the Hadal zone was sterile. Since then, remotely operated vehicles and deep-diving landers have revealed a surprising diversity of life in the trenches. One of the most remarkable inhabitants of the Hadal zone is the amphipod, a small shrimp-like crustacean that has adapted to the crushing pressure and cold. Some species of amphipods found in the trenches are giants compared to their shallow water relatives, growing up to 10 times larger. Their bodies are flexible and resilient, able to withstand the immense weight of the water above. These amphipods are scavengers, feeding on the organic debris that drifts down from the upper layers of the ocean. Everything from dead fish to fragments of wood and even the occasional whale carcass. Another extraordinary resident is the Hadal snailfish, a ghostly, translucent creature that glides through the darkness with an almost ethereal grace. The Hadal snailfish holds the record for the deepest living fish ever discovered, found at depths exceeding 8,000 meters. Its body is soft and gelatinous, lacking the heavy bones of surface fish, which would be crushed by the pressure. Instead, it relies on a unique set of proteins and enzymes that keep its cells functioning in the extreme cold and pressure. The snailfish's skin is nearly transparent, and its organs are visible through its body, a living window into the mysteries of adaptation. But the Hadal zone is not just home to scavengers and soft-bodied fish. Recent expeditions have uncovered a host of other organisms, giant single-celled xenophyophores, which form intricate branching structures on the seafloor. tiny, resilient worms that burrow into the mud, and bacteria that thrive on the chemical energy released by the slow decay of organic matter. Some of these microbes are capable of breaking down pollutants and even plastics, offering hope for new solutions to the problem of ocean pollution. The existence of life in the trenches raises profound questions about the limits of biology. How do these creatures survive in such extreme conditions? What genetic and biochemical adaptations allow them to function where others cannot? And what does their presence tell us about the potential for life in other extreme environments, both on Earth and beyond? The Hadal Zone is also a place of constant change. The trenches are shaped by the movement of tectonic plates, and earthquakes and landslides are common. These events can reshape the landscape in an instant, burying entire communities and creating new habitats. The organisms that live here must be resilient, able to adapt to sudden changes in their environment. Some species may even rely on these disturbances, taking advantage of the new resources that are exposed by a landslide or the fresh nutrients brought in by a current. Despite the challenges, the Hadal Zone is a place of surprising abundance. In some trenches, researchers have found dense aggregations of amphipods and other scavengers, drawn by the promise of food. In others, fields of xenophyophores cover the seafloor, creating a patchwork of life in the darkness. Each trench is unique, shaped by its geology, chemistry, and history, and each one holds secrets that have yet to be uncovered. As we continue our journey into the deep, the Hadal Zone stands as a testament to the resilience and adaptability of life. The creatures that inhabit these depths are living proof that the boundaries of the possible are far wider than we once believed. They challenge our assumptions about where life can exist and how it can evolve in isolation. But for all we have discovered, the trenches remain a frontier. Most of the Hadal Zone has never been explored, and new species are discovered with every expedition. What other wonders might be waiting in the darkness? What unknown creatures might be lurking in the unexplored trenches of the world's oceans? And what can these communities teach us about the origins and limits of life itself? In the next section, we will explore the remarkable adaptations that allow deep-sea creatures to survive in the face of such overwhelming challenges. From the molecular tricks that protect their cells to the unique strategies they use to find food and mates, the story of survival in the deep is one of ingenuity and persistence. The journey continues and the mysteries only deepen. Survival in the deep sea is a feat that demands extraordinary ingenuity. The creatures that inhabit these depths are not merely survivors. They are masters of adaptation, equipped with a suite of biological tools that allow them to endure conditions that would be instantly fatal to most life on Earth. To understand how these animals persist in the abyss, we must look closely at the remarkable strategies they employ, from the molecular level to the grand scale of their behaviors. The first and most obvious challenge is pressure. At the bottom of the Mariana Trench, the pressure is more than 1,000 times that at sea level, enough to crush a human-made submarine if not properly engineered. Deep-sea creatures have evolved bodies that are both flexible and resilient. Many, like the Hadal snailfish, lack rigid bones and instead have cartilage and gelatinous tissues that can withstand the immense weight of the water above. Their cell membranes are specially adapted, containing unique lipids that remain fluid even under crushing pressure. Some species produce piezolates, small molecules that stabilize proteins and prevent them from collapsing under stress. These adaptations are so effective that if brought to the surface too quickly, many deep-sea animals simply disintegrate. Their bodies are built for the deep, and only the deep temperature is another formidable barrier. The deep ocean is a world of perpetual cold, with temperatures hovering just above freezing. Enzymes and proteins that function at the surface would become sluggish or inactive in such conditions. But deep-sea organisms have evolved versions that remain active at low temperatures. Some fish produce antifreeze proteins in their blood, preventing ice crystals from forming in their tissues. Others have slow metabolisms, conserving energy and allowing them to survive on the meager scraps of food that drift down from above. Food scarcity is perhaps the most relentless challenge of all. In the absence of sunlight, there is no photosynthesis, and the only source of energy is the marine snow, a constant rain of organic debris from the surface. This includes dead plankton, fish scales, fecal pellets, and the occasional carcass of a larger animal. Deep-sea scavengers are opportunists, able to detect the faintest traces of food from kilometers away. Some, like the amphipods, have highly sensitive antennae that can pick up chemical cues in the water, guiding them to a meal. Others, like the hagfish, are equipped with powerful jaws and teeth that allow them to tear through tough flesh and bone. But not all deep-sea creatures are scavengers. Some are predators, equipped with adaptations that make them formidable hunters in the darkness. The anglerfish, with its bioluminescent lure, is a classic example. Other fish, like the dragonfish, have enormous mouths and expandable stomachs, allowing them to swallow prey nearly as large as themselves. Many deep-sea predators have evolved long needle-like teeth and jaws that can unhinge, ensuring that no meal is ever wasted. Communication and reproduction in the deep sea present their own unique challenges. In a world without light, many animals rely on bioluminescence to find mates and signal their presence. Some species produce complex patterns of light, flashing in sequences that are unique to their kind. Others release chemical signals, pheromones that can travel long distances in the water, guiding potential mates together in the vast emptiness. For some, like the anglerfish, the solution is even more extreme. Males fuse their bodies to females, becoming permanent, living appendages that provide sperm on demand. The deep sea is also a world of slow motion. Many creatures grow slowly, live long lives, and reproduce infrequently. This is a strategy born of necessity. Resources are scarce and the risks of reproduction are high. Some deep-sea corals and tube worms can live for centuries, their slow growth a testament to the patience required to survive in the abyss. Yet, for all their adaptations, deep-sea creatures are vulnerable to change. The stability of their environment is both a blessing and a curse. While it allows for the evolution of highly specialized forms, it also means that even small disturbances, such as changes in temperature, chemistry, or food supply, can have devastating effects. As human activity increasingly encroaches on the deep ocean, from deep-sea mining to climate change, the resilience of these remarkable animals is being put to the test. The story of adaptation in the deep sea is one of constant innovation. Every creature is a living experiment, a unique solution to the challenges of life in the darkness. Their existence expands our understanding of what is possible, and their survival offers hope that life can persist even in the most unlikely places. But the deep sea is not just a laboratory for studying adaptation. It is also a window into the past. Many of the creatures that inhabit the abyss are living fossils, their lineages stretching back hundreds of millions of years. By studying their genetics and physiology, scientists hope to unlock the secrets of evolution itself, tracing the pathways that have led from the first simple cells to the dazzling diversity of life we see today. In the next section, we will meet some of the most enigmatic and controversial creatures of the deep, organisms that challenge our very definitions of life and raise profound questions about the nature of existence. From the immortal jellyfish to the mysterious xenophyophores, these beings blur the boundaries between animal, plant, and microbe. Their stories may hold the key to understanding not only the deep sea, but the very origins of life on Earth. Among the most enigmatic inhabitants of the deep sea are creatures that seem to defy the very categories by which we define life. These organisms, often overlooked or misunderstood, challenge our assumptions about what it means to be alive. They blur the lines between animal, plant, and microbe, and their existence raises profound questions about the origins and possibilities of life, not just in the ocean, but across the universe. Consider the xenophyophores, giant single-celled organisms that dwell on the abyssal plains and in the deepest trenches. At first glance, they resemble strange, branching corals or sponges, but each is a single cell, albeit one that can reach up to 20 centimeters across, making them among the largest single-celled organisms on Earth. Xenophyphories build intricate, branching structures from particles of sediment, creating miniature landscapes on the seafloor. Their bodies are filled with a mysterious jelly-like substance, and their internal architecture is a labyrinth of vacuoles and granules. Scientists are still unraveling the secrets of their biology. How do they grow so large? How do they survive the crushing pressures and low nutrient levels of the deep? And what role do they play in the ecosystem, as both habitat and filter for other tiny life forms? Then there is the immortal jellyfish, Turritopsis dohrnii, a creature whose life cycle seems to mock the inevitability of death. Found in deep and shallow waters alike, this tiny jellyfish possesses a remarkable ability. When faced with injury, starvation, or old age, it can revert its cells to an earlier stage of development, essentially starting its life over again. This process, known as transdifferentiation, allows the jellyfish to bypass death and achieve a kind of biological immortality. While most individuals eventually succumb to disease or predation, the potential for endless regeneration has made the immortal jellyfish a subject of intense scientific interest. Could the secrets of its cellular machinery one day help us understand aging, or even extend human life? Other deep-sea creatures challenge our understanding in different ways. The siphonophores, for example, are colonial animals composed of many specialized individuals, each performing a different function, some for feeding, others for movement, still others for reproduction. Together, they form a single integrated organism that can stretch for tens of meters through the water, glowing with bioluminescent light. The Portuguese man-o'-war, a relative of the siphonophores, is another example of this collective approach to life, a floating colony that is both one creature and many. The deep sea is also home to extremophils, microbes that thrive in conditions that would be lethal to most other forms of life. Some live in the scalding waters of hydrothermal vents, others in the freezing brine pools of the abyss, and still others in the toxic anoxic muds of cold seeps. These organisms have evolved unique enzymes and metabolic pathways that allow them to survive in the presence of heavy metals, high salinity, and even radioactive materials. Their resilience has made them a focus of research into the origins of life, as well as the search for life on other planets. Perhaps most mysterious of all are the living fossils of the deep, creatures whose lineages stretch back hundreds of millions of years, virtually unchanged since the dawn of complex life. The coelacanth, once thought extinct, was rediscovered in the deep waters off South Africa in 1938. This ancient fish, with its lobed fins and primitive lungs, is a window into the distant past, a living reminder of the evolutionary experiments that shaped the history of life on Earth. Similarly, the giant isopod, a deep-sea relative of the pillbug, has remained largely unchanged for over 160 million years, its armored body perfectly suited to the slow, scavenging life of the abyss. These enigmatic creatures are more than just curiosities. They are living laboratories, offering insights into the fundamental processes of biology. By studying their genetics, physiology, and behavior, scientists hope to unlock the secrets of adaptation, regeneration, and survival. What can the immortal jellyfish teach us about aging? How do xenophyphories build their intricate structures? And what can they reveal about the limits of cellular complexity? Can extremophils help us understand how life might arise on other worlds? Or even inspire new technologies for medicine and industry? The answers to these questions are still emerging, but one thing is clear. The deep sea is a place where the boundaries of the possible are constantly being redrawn. Every new discovery challenges our assumptions and expands our sense of wonder. The creatures that inhabit the abyss are not just survivors, they are pioneers, exploring the frontiers of biology and showing us that life is more resilient, more adaptable, and more mysterious than we ever imagined. As we continue our journey, we will turn our attention to the role of deep-sea creatures in the broader ecosystem of the planet. How do these animals influence the cycling of nutrients and energy in the ocean? What impact do they have on the global climate? And what threats do they face from human activity? The story of the deep sea is not just a tale of survival, It is a story of connection, resilience, and the delicate balance that sustains life on Earth. The deep sea, for all its isolation and mystery, is not a world apart. It is intimately connected to the rest of the planet, playing a vital role in the cycling of nutrients, the regulation of climate, and the health of the global ecosystem. The creatures that inhabit the abyss are not just passive residents of a remote frontier. They are active participants in the great web of life, shaping the ocean in ways both subtle and profound. One of the most important roles played by deep-sea organisms is in the recycling of organic matter. Every day, countless tons of dead plankton, fish, and other debris sink from the sunlit surface to the dark depths below. This marine snow is the primary source of food for many deep-sea creatures, from tiny bacteria to giant amphipods and isopods. As these animals feed, they break down the organic material, releasing nutrients back into the water and making them available for other organisms. In this way, the deep sea acts as the planet's ultimate recycling center, ensuring that nothing is wasted and that the cycle of life continues. But the influence of the deep sea goes even further. Many deep sea creatures play a crucial role in the global carbon cycle, helping to regulate the amount of carbon dioxide in the atmosphere. When marine snow sinks to the seafloor, some of the carbon it contains is buried in the sediments, effectively removing it from the atmosphere for thousands or even millions of years. This process, known as the biological pump, helps to moderate the Earth's climate, preventing runaway warming and maintaining the delicate balance that makes life possible. Some of the most important players in this process are the tiny, often invisible microbes that inhabit the deep. These bacteria and archaea are masters of chemical transformation, capable of breaking down complex molecules and recycling nutrients in ways that no other organisms can. In the cold, dark muds of the abyss, they convert methane and hydrogen sulfide into energy, supporting entire ecosystems and preventing the buildup of toxic gases. In the sediments of the deep, they help to lock away carbon, nitrogen, and other elements, shaping the chemistry of the ocean and the atmosphere. The deep sea is also a reservoir of biodiversity, home to countless species that have yet to be discovered or described. Each new expedition reveals creatures that are stranger and more wonderful than the last. Animals with unique adaptations, novel biochemistries, and life histories that challenge our understanding of evolution. This hidden diversity is not just a source of wonder. It is a treasure trove of potential resources for medicine, biotechnology, and industry. Enzymes from deep-sea microbes are already being used in the development of new drugs, industrial processes, and even the search for life on other planets. Yet, for all its resilience, the deep sea is not immune to the impacts of human activity. In recent years, the growing demand for minerals, energy, and food has driven exploration and exploitation of the deep ocean on an unprecedented scale. Deep-sea mining, oil and gas extraction, and bottom trawling threaten to disrupt fragile ecosystems that have taken millions of years to evolve. Pollution from plastics, chemicals, and even noise is reaching the most remote corners of the abyss, with unknown consequences for the creatures that live there. Climate change poses an even greater threat. As the planet warms, the chemistry and circulation of the ocean are changing, with potentially devastating effects on deep-sea life. The warming of surface waters can reduce the amount of oxygen that reaches the depths, creating dead zones where few organisms can survive. Changes in the supply of marine snow can alter the balance of food and energy, disrupting the delicate web of life that sustains the abyss. Even small shifts in temperature or chemistry can have outsized impacts on creatures that are exquisitely adapted to stable, unchanging conditions. Despite these challenges, the deep sea remains a place of hope and possibility. Its resilience and adaptability offer lessons for the future, showing us that life can persist even in the face of overwhelming odds. The creatures of the deep are not just survivors, they are innovators, constantly finding new ways to thrive in a changing world. Their stories remind us of the interconnectedness of all life, and of our responsibility to protect the planet's last great wilderness. As we look to the future, the need for exploration and conservation has never been greater. The deep sea holds answers to some of the most pressing questions of our time. How does life adapt to extreme environments? What are the limits of survival? And what can we learn from the creatures of the abyss about resilience, innovation, and the power of connection? In the next section, we will journey into the world of deep-sea exploration itself, meeting the scientists, engineers, and explorers who risk everything to unlock the secrets of the ocean's depths. Their stories are tales of courage, curiosity, and discovery, proof that the human spirit is as restless and resilient as the creatures we seek to understand. The adventure continues, and the mysteries of the deep are far from exhausted. The story of deep-sea exploration is a saga of human curiosity and ingenuity, a testament to our relentless desire to understand the unknown. For centuries, the ocean's depths were a realm of myth and speculation, a place where monsters lurked and ships vanished without a trace. But as technology advanced and our hunger for knowledge grew, a new generation of explorers set out to pierce the darkness and reveal the secrets of the abyss. The earliest attempts to explore the deep were humble and fraught with danger. In the 19th century, scientists used weighted lines and dredges to sample the seafloor, pulling up mud, rocks, and the occasional strange creature. The HMS Challenger expedition of the 1870s was a turning point, mapping the ocean's depths and discovering thousands of new species. Yet for all their achievements, these pioneers could only guess at what lay beyond the reach of their instruments. The real revolution began in the 20th century, with the invention of submersibles, specially designed vessels capable of withstanding the crushing pressures of the deep. In 1960, the bathyscaphe Trieste made history when Jacques Piccard and Don Walsh descended to the bottom of the Mariana Trench, reaching a depth of nearly 11,000 meters. Their journey was a triumph of engineering and courage, a moment that proved the deep sea was not beyond human reach. For 20 minutes they gazed out at a landscape no one had ever seen, their tiny window framing a world of mud, silence, and the occasional flicker of life. Since then, the tools of exploration have grown ever more sophisticated. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, now allow scientists to explore the deep for days or even weeks at a time, capturing high-definition video, collecting samples, and mapping the seafloor in exquisite detail. These robotic explorers have revealed a world of staggering diversity and complexity. Forests of tube worms clustered around hydrothermal vents, swarms of shrimp feeding on chemical plumes, and jellyfish that pulse with their own internal light. But the human spirit remains at the heart of deep-sea exploration. Modern explorers like Dr. Sylvia Earle, Dr. Robert Ballard, and Victor Vescovo have pushed the boundaries of what is possible, descending to the ocean's greatest depths and bringing back stories and images that have captivated the world. Their missions are not just scientific, they are acts of wonder, driven by a belief that the unknown is worth knowing, and that the mysteries of the deep are as important as those of the stars. The challenges of deep-sea exploration are immense. The pressure at depth is enough to crush steel, and the cold can freeze electronics in an instant. Communication with the surface is limited and the darkness is absolute. Every expedition is a test of technology, planning, and nerve. Yet with each dive, the boundaries of the possible are pushed further, and the map of the unknown grows smaller. The discoveries made by deep-sea explorers have transformed our understanding of the planet. They have revealed ecosystems that operate on principles entirely different from those of the surface, driven not by sunlight, but by chemical energy. They have found creatures that challenge our definitions of life, and geological features that reshape our understanding of Earth's history. They have uncovered shipwrecks and lost cities, offering glimpses into the past and the enduring power of the ocean to both preserve and destroy. Yet for all the progress, the deep sea remains a frontier. More than 80% of the ocean is still unexplored, its secrets hidden beneath miles of water. Every expedition brings new surprises, creatures that defy classification, ecosystems that operate on principles we barely understand, and geological features that rewrite our understanding of the planet itself. The work of deep-sea explorers is not just about discovery, it is also about stewardship. As human activity increasingly encroaches on the deep ocean, the need to understand and protect these fragile ecosystems has never been greater. The data and samples collected by explorers are vital for conservation, helping to inform policies and practices that can safeguard the ocean for future generations. The spirit of exploration is alive and well, fueled by advances in technology and a growing recognition of the deep sea's importance to the health of the planet. New missions are being planned to map the ocean floor, study the effects of climate change, and search for life in the most extreme environments. International collaborations are bringing together scientists, engineers, and policymakers from around the world, united by a common goal: to unlock the secrets of the deep and ensure its survival. As we look to the future, the possibilities are as vast as the ocean itself. The next generation of explorers will build on the achievements of those who came before, venturing deeper, staying longer, and discovering more. Their work will not only expand our knowledge of the deep sea, but also inspire new generations to dream, to wonder, and to explore. In the next section, we will delve into the stories of some of the most remarkable discoveries made in the deep, moments when the unknown became known, and the impossible became real. These are the stories that remind us why we explore and why the question, "Are we alone?" is as much about the journey as it is about the answer. The history of deep-sea exploration is punctuated by moments of revelation, discoveries that have forever changed our understanding of life and the planet. These are the stories that ignite the imagination, that remind us how much remains unknown, and that prove the ocean's depths are as rich in wonder as any alien world. One such moment came in 1977, when a team of scientists aboard the research vessel Alvin descended to the Galapagos Rift, a volcanic ridge deep beneath the Pacific. They expected to find a barren wasteland, but instead their lights revealed a thriving community of giant tube worms, clams, and crabs clustered around hydrothermal vents. The water here was superheated and toxic, yet life flourished in abundance. The secret was chemosynthesis. Bacteria living inside the tube worms converted chemicals from the vent water into energy, supporting an entire ecosystem independent of sunlight. This discovery shattered the long-held belief that all life on Earth depended on the sun, opening new possibilities for life in the universe. Another milestone came with the discovery of the black smoker vents, towering chimneys that spew dark, mineral-rich water into the ocean. Around these vents, scientists found new species at every turn: blind shrimp that sense heat, giant mussels with symbiotic bacteria, and even yeti crabs with hairy pincers that farm bacteria on their bodies. Each new creature was a marvel of adaptation, a living answer to the question of how life can persist in the most extreme environments. The deep sea has also yielded creatures that seem to belong to another world. In 2012, researchers exploring the Mariana Trench captured footage of the deepest living fish ever recorded, a ghostly snailfish gliding through the darkness at nearly 8,200 meters. Its body was soft and translucent, its organs visible through its skin, and its presence at such depth challenged everything scientists thought they knew about the limits of vertebrate life. The snailfish's discovery was a reminder that the deep still holds secrets waiting to be revealed. Some discoveries have come not from living creatures, but from the traces they leave behind. In the sediments of the abyss, scientists have found the remains of ancient microbes, preserved for millions of years. These microbial fossils offer clues to the history of life on Earth, and may even help us recognize signs of life on other planets. In other cases, researchers have uncovered the bones of whales and other large animals, their skeletons forming the basis of unique ecosystems known as whale falls. As the carcass decays, It provides food and habitat for a succession of deep-sea creatures. From scavenging hagfish to bone-eating worms, each whale fall is a microcosm of the deep, a reminder of the interconnectedness of life and death in the ocean. The deep sea has also revealed evidence of ancient catastrophes and lost worlds. In the sediments of the Atlantic, scientists have found layers of iridium-rich clay, a signature of the asteroid impact that ended the age of the dinosaurs. In the Mediterranean, they have discovered submerged cities and shipwrecks, preserved for centuries in the cold, dark waters. These finds are windows into the past, offering glimpses of vanished civilizations and the forces that have shaped the planet. Yet for every discovery, there are countless mysteries that remain unsolved. What unknown creatures lurk in the unexplored trenches and seamounts? How do deep-sea animals navigate, communicate, and find mates in the darkness? What secrets are hidden in the genomes of the abyss's most enigmatic inhabitants? Each answer leads to new questions, and the sense of wonder only grows. The stories of discovery are not just about science, they are about the human spirit. They are tales of perseverance, curiosity, and the willingness to venture into the unknown. The scientists and explorers who have braved the deep have faced danger, disappointment, and failure. But they have also experienced moments of awe and revelation that few others can imagine. Their work is a testament to the power of exploration, and to the idea that the greatest discoveries are often those we never expected to find. As we reflect on these stories, we are reminded that the deep sea is not just a place of darkness and danger. It is a place of possibility. Every new expedition is a chance to rewrite the story of life on Earth, to expand the boundaries of the possible, and to glimpse the extraordinary in the ordinary. The creatures of the deep are not just survivors, they are pioneers, showing us that life can flourish in the most unlikely places. In the next section, we will explore the role of technology in unlocking the secrets of the deep. From the earliest submersibles to the latest robotic explorers, technology has been the key to our progress, and the promise of even greater discoveries to come. The journey is far from over, and the next chapter may be the most exciting yet. The story of deep-sea discovery is inseparable from the story of technology. Every leap in our understanding of the abyss has been made possible by the tools we build, the vessels, sensors, cameras, and robots that allow us to reach where no human could survive. The evolution of deep-sea technology is a tale of relentless innovation, driven by the desire to see, to touch, and to understand the most inaccessible places on Earth. The earliest explorers of the deep relied on simple tools, weighted lines, dredges, and nets lowered from ships. These methods were crude and often destructive, but they yielded the first tantalizing glimpses of life in the darkness, strange fish, delicate corals, and mysterious muds that hinted at a world beyond imagination. The invention of the bathysphere in the 1930s marked a turning point. This steel ball, barely large enough for two people, was lowered by cable into the depths, allowing William Beebe and Otis Barton to become the first humans to witness the twilight zone firsthand. Their descriptions of glowing jellyfish and monstrous fish captured the public's imagination and set the stage for a new era of exploration. The development of the bathyscaphe, a free-diving submersible, opened the door to even greater depths. The Trieste's historic dive to the bottom of the Mariana Trench in 1960 was a triumph of engineering, but it was also a reminder of the challenges that remain. The descent took nearly 5 hours, and the tiny window offered only a limited view of the sea floor. Communication with the surface was tenuous, and the risk of disaster was ever present. Yet the success of the mission proved that the deep was not beyond our reach. In the decades that followed, advances in materials science, electronics, and robotics transformed the field. Remotely operated vehicles, ROVs, became the workhorses of deep-sea research, capable of diving to great depths, collecting samples, and transmitting high-definition video in real time. These robotic explorers are equipped with manipulator arms, sensors, and lights that can illuminate the darkest corners of the ocean. They have discovered new species, mapped hydrothermal vents, and even explored the wreck of the Titanic. Autonomous underwater vehicles, AUVs, have added a new dimension, able to operate independently for days or weeks, mapping vast areas of the seafloor and gathering data on everything from temperature to chemistry to sound. The latest generation of deep-sea technology is pushing the boundaries even further. Advanced submersibles like Alvin, Limiting Factor, and Shinkai 6500 can carry scientists to depths of 6,000 meters or more, allowing for direct observation and experimentation. These vessels are equipped with state-of-the-art navigation systems, life support, and communication tools, making it possible to conduct complex research in real time. High-resolution cameras and 3D imaging systems provide unprecedented views of the seafloor, revealing details that were once invisible. But technology is not just about going deeper. It's about seeing more, understanding more, and sharing discoveries with the world. New sensors can detect the faintest traces of chemicals, DNA, and even sound, allowing scientists to study the behavior and interactions of deep-sea creatures in their natural habitat. Environmental DNA (eDNA) sampling has revolutionized the search for new species, enabling researchers to identify organisms from the genetic material they leave behind in the water. This non-invasive approach is opening new windows into the hidden diversity of the deep. Communication technology has also transformed the way we explore. Live-streamed dives, virtual reality experiences, and interactive mapping tools allow people around the world to join in the adventure, witnessing discoveries as they happen. Citizen science projects invite the public to help classify images, identify species, and contribute to the growing body of knowledge about the deep sea. The boundaries between scientist and explorer, expert and enthusiast, are blurring, creating a global community united by curiosity and wonder. Yet, for all its power, technology is only a tool. The true engine of discovery is the human spirit, the drive to ask questions, to seek answers, and to push beyond the limits of the known. Every new invention, every daring dive, is a testament to our capacity for imagination and perseverance. The challenges of the deep are immense, but so too are the rewards: new knowledge, new perspectives, and a deeper appreciation for the complexity and beauty of our planet. As we look to the future, the possibilities are staggering. Advances in artificial intelligence, robotics, and material science promise to make the deep more accessible than ever before. Swarms of autonomous vehicles could map the entire ocean floor, while new sensors could reveal the hidden chemistry of the abyss. The search for life on other planets will draw on the lessons and technologies developed in the deep. As we look for signs of life in the subsurface oceans of Europa, Enceladus, and beyond. In the next section, we will explore the ethical and philosophical questions raised by our exploration of the deep. As we unlock the secrets of the abyss, we must also confront the responsibilities that come with knowledge. How do we balance discovery with conservation? What does it mean to protect a world we are only just beginning to understand? The journey into the deep is not just a scientific adventure, it is a moral one, and the choices we make will shape the future of the ocean and of life itself. As our reach into the deep sea extends, so too does our responsibility. The ocean's depths, once thought to be beyond the touch of human influence, are now recognized as vulnerable and precious. The ethical and philosophical questions that arise from our exploration are as profound as the scientific mysteries we seek to solve. What does it mean to discover a world, only to realize we might harm it? How do we balance the thrill of discovery with the duty of stewardship? The deep sea is a realm of slow time and fragile balance. Many of its creatures grow slowly, live for centuries, and reproduce infrequently. The ecosystems that form around hydrothermal vents, cold seeps, and whale falls are the result of millions of years of evolution, their intricate webs of life, delicately tuned to the chemistry and stability of their environment. A single disturbance, whether from mining, pollution, or climate change, can disrupt these systems in ways that may take centuries to repair, if they recover at all. Deep-sea mining is perhaps the most pressing ethical challenge. The demand for rare minerals used in electronics, batteries, and renewable energy technologies has driven interest in extracting resources from the ocean floor. Vast fields of polymetallic nodules, hydrothermal vent deposits, and cobalt-rich crusts are seen as potential treasure troves. But the cost of extraction is high. Mining operations can destroy habitats, release toxic sediments, and create noise and light pollution that disrupt the lives of deep-sea creatures. The full impact of these activities is still unknown, but early studies suggest that recovery, if it happens at all, may take thousands of years. The question of conservation is complicated by the fact that the deep sea is largely uncharted. We cannot protect what we do not know exists. Every new expedition reveals species, habitats, and interactions that were previously invisible. The discovery of a new vent field or a unique community of xenophyophores can shift our understanding of what is at stake. This uncertainty demands caution, a recognition that the deep is not an inexhaustible resource, but a living system whose value goes far beyond the minerals it contains. International law and policy are struggling to keep pace with the realities of deep-sea exploration. The United Nations Convention on the Law of the Sea, UNCLOS, provides a framework for managing the ocean's resources, but enforcement is difficult, and many areas remain outside national jurisdiction. The International Seabed Authority, ISA, is tasked with regulating mining in international waters, but critics argue that its processes are slow and its protections inadequate. As technology makes the deep more accessible, the need for clear, enforceable rules has never been greater. Beyond the legal and political challenges lie deeper philosophical questions. What is the value of a world we may never see? Do the creatures of the abyss have a right to exist, independent of their usefulness to humans? Is the deep sea a wilderness to be preserved, a resource to be used, or something else entirely? These are questions without easy answers, but they are essential to consider as we chart the future of exploration. The deep sea also forces us to confront our own limitations. For all our technology and ambition, we are still newcomers in a world that has existed for billions of years. Our understanding is partial, our presence fleeting. The creatures of the deep have survived ice ages, asteroid impacts, and the shifting of continents. Their resilience is a lesson in humility, a reminder that life is both fragile and enduring. Yet there is hope. The growing awareness of the deep sea's importance has inspired new efforts to protect it. Marine protected areas are being established in some of the most vulnerable regions, and international collaborations are working to map and monitor the ocean's depths. Scientists, policymakers, and the public are coming together to advocate for responsible stewardship, recognizing that the health of the deep is inseparable from the health of the planet. The ethical journey into the deep is ongoing. Every discovery brings new responsibilities, and every question answered raises new dilemmas. The challenge is to balance curiosity with care, to explore without exploiting, and to recognize that the greatest treasures of the deep may be the ones we choose to leave untouched. As we continue our journey, we must ask ourselves, what kind of explorers do we want to be? Will we be conquerors, extracting what we can and leaving scars behind? Or will we be stewards, learning from the deep and protecting its wonders for generations to come? The answer will shape not only the future of the ocean, but the legacy we leave as a species. In the next section, we will return to the creatures themselves, exploring the ways in which deep-sea life has inspired art, literature, and the human imagination. The abyss is not just a scientific frontier. It is a wellspring of wonder, a source of stories and symbols that have shaped our culture for centuries. The journey into the deep is as much about the heart as it is about the mind, and the creatures that dwell there have lessons to teach us all. The deep sea has always been more than a scientific frontier. It is a realm that has haunted the human imagination for centuries. Long before the first submersible ever touched the ocean floor, the abyss was a place of myth, legend, and artistic inspiration. Its darkness and mystery have served as a canvas for our fears, our hopes, and our sense of wonder. The creatures that dwell in the deep have become symbols in our stories, metaphors in our art, and muses for our creativity. In ancient times, the ocean's depths were believed to be the domain of gods and monsters. The Greeks imagined Poseidon's palace beneath the waves, surrounded by sea nymphs and strange beasts. Sailors told tales of the Kraken, a giant cephalopod capable of dragging ships to their doom, and of mermaids whose songs lured men to watery graves. These stories were not just entertainment. They were ways of grappling with the unknown, of giving shape to the fears and fascinations that the deep inspired. As science advanced and the true nature of the abyss began to emerge, the deep sea's influence on art and literature only grew. The 19th century saw a surge of fascination with the ocean's mysteries, fueled by the voyages of exploration and the discoveries of new and bizarre creatures. Writers like Jules Verne captured the public's imagination with tales of undersea adventure. In 20,000 Leagues Under the Seas, Captain Nemo's Nautilus travels through forests of coral, past giant squids, and into the heart of the unknown. Verne's vision was both prophetic and poetic, blending scientific possibility with the romance of discovery. The deep sea has also inspired visual artists, from the swirling, dreamlike paintings of the symbolists to the surreal, otherworldly creatures of modern illustration. The forms and colors of deep-sea life, bioluminescent jellies, translucent fish, and alien-like invertebrates, have found their way into everything from jewelry to fashion to film. The abyss is a source of endless visual fascination, its inhabitants both beautiful and bizarre. In cinema, the deep sea has been a setting for both horror and wonder. Films like The Abyss, Sphere, and Finding Nemo have explored the ocean's depths as places of danger, discovery, and transformation. The creatures of the deep, real and imagined, have become icons of the unknown. Their glowing bodies and monstrous shapes a reminder of how much remains hidden beneath the waves. Even in popular culture, the deep sea exerts a powerful pull, inspiring video games, comics, and music that evoke its mystery and majesty. But the influence of the deep is not limited to the arts. It has shaped our language, our philosophy, and our sense of ourselves. The phrase plumbing the depths has come to mean exploring the unknown, facing our fears, or seeking hidden truths. The abyss is a metaphor for the unconscious, the unexplored, the infinite. It is a place where boundaries dissolve, where the familiar becomes strange, and where the impossible becomes real. The creatures of the deep, in all their strangeness, have become symbols of resilience, adaptation, and the power of life to persist against all odds. The anglerfish, with its glowing lure, is a lesson in patience and cunning. The immortal jellyfish is a symbol of renewal and transformation. The giant squid, once a monster of legend, is now a reminder of the limits of our knowledge and the endless possibilities that remain. The deep sea also challenges us to see beauty in the unfamiliar. Its creatures are not always conventionally attractive. Some are grotesque, even frightening. Yet in their adaptations, their colors, and their forms, there is a kind of artistry that rivals anything found on land. The bioluminescent displays of the abyss are light shows more dazzling than any fireworks. And the delicate structures of deep-sea corals are sculptures shaped by time and tide. In recent years, artists and scientists have begun to collaborate, using the tools of both disciplines to explore and celebrate the deep. Expeditions now often include writers, painters, and filmmakers, whose work brings the wonders of the abyss to a wider audience. Museums and aquariums create immersive exhibits that allow visitors to experience the deep through sound, light, and touch. These collaborations are more than just outreach. They are a recognition that the deep sea belongs to all of us, and that its mysteries are as much a part of our cultural heritage as our scientific knowledge. The deep sea's influence on the human imagination is a testament to its power. It is a place that invites us to dream, to wonder, and to ask questions that have no easy answers. Its creatures are reminders that life is not limited by our expectations, and that the world is richer, stranger, and more beautiful than we can imagine. As we approach the final chapters of our journey, we will turn our attention to the future. What new discoveries await in the unexplored corners of the abyss? How will advances in technology, science, and art shape our understanding of the deep? And what role will the deep sea play in the story of life on Earth and perhaps beyond? The adventure is far from over, and the next wave of exploration may reveal wonders we have not yet dreamed. The future of deep-sea exploration is a horizon shimmering with promise and uncertainty. As technology accelerates and our curiosity deepens, the next era of discovery is poised to reveal wonders that will challenge not only our scientific understanding, but also our sense of what it means to be alive on this planet. The abyss, once a realm of myth and fear, is now a frontier of hope, a place where the next great questions of biology, ecology, and even philosophy may be answered. One of the most exciting prospects is the continued search for new life. With every expedition, scientists are reminded that the deep sea is far from fully explored. In fact, it is estimated that as much as 90% of deep-sea species remain undiscovered. Each new dive brings the possibility of encountering creatures that defy classification, animals with forms, behaviors, and biochemistries unlike anything seen before. The discovery of new species is not just a matter of adding names to a list. It is a window into the processes of evolution, adaptation, and survival that have shaped life in the most extreme environments on Earth. Advances in genetic technology are revolutionizing the way we study the deep. Environmental DNA, eDNA sampling, allows researchers to detect the presence of organisms from the genetic material they leave behind in the water. This technique is revealing a hidden world of diversity, uncovering species that have never been seen or collected. As sequencing becomes faster and more affordable, the genetic blueprints of deep-sea life are being decoded, offering insights into the molecular machinery that enables survival in the abyss. These discoveries have implications far beyond the ocean, informing fields as diverse as medicine, biotechnology, and astrobiology. The search for life is not limited to Earth. The lessons learned from the deep sea are guiding the search for life on other worlds, particularly the icy moons of Jupiter and Saturn. Europa and Enceladus are believed to harbor subsurface oceans, kept liquid by tidal heating and possibly enriched by hydrothermal activity. If life can thrive around Earth's hydrothermal vents, independent of sunlight, could similar ecosystems exist beneath the ice of distant moons? Robotic missions are being designed to probe these alien oceans, drawing on the technologies and strategies developed for deep-sea exploration. The question, "Are we alone?" may one day be answered not by looking to the stars, but by looking into the darkness beneath another world's surface. Closer to home, the future of deep-sea research will depend on collaboration and innovation. International partnerships are essential for mapping the ocean floor, sharing data, and developing new technologies. The United Nations Decade of Ocean Science for Sustainable Development 2021-2030 is a global effort to advance our understanding of the ocean and ensure its health for future generations. Projects like Seabed 2030 aim to map the entire ocean floor in high resolution, revealing the contours of the abyss and the habitats it contains. But exploration is not just about discovery, it is also about protection. As the threats to the deep sea grow, from mining to climate change, the need for effective conservation has never been greater. Scientists, policymakers, and the public must work together to create marine protected areas, regulate resource extraction, and monitor the impacts of human activity. The deep sea is a common heritage, a legacy that belongs to all of humanity and to the generations yet to come. Education and outreach will play a crucial role in shaping the future. The wonders of the deep must be shared, not just with scientists and policymakers, but with everyone. Virtual reality, live-streamed dives, and interactive exhibits can bring the abyss into classrooms and living rooms around the world. Citizen science projects can engage people of all ages in the process of discovery, turning curiosity into action and stewardship. The future will also be shaped by the unexpected. The deep sea is a place of surprises where every answer leads to new questions. The discovery of a new ecosystem, the sighting of a never-before-seen creature, or the unraveling of a genetic mystery can shift the course of research and open new avenues of inquiry. The abyss is a reminder that the world is not finished, that there are still frontiers to explore and mysteries to solve. As we look ahead, the deep sea stands as both a challenge and an inspiration. It is a place that demands humility, patience, and imagination. It asks us to think beyond the boundaries of the familiar, to embrace the unknown, and to recognize the interconnectedness of all life. The creatures that dwell in the darkness are not just survivors, they are teachers, showing us that life is resilient, adaptable, and endlessly creative. In the next section, we will reflect on the philosophical and existential questions raised by our journey into the deep. What does it mean to search for life in the most unlikely places? How does the existence of deep-sea creatures reshape our understanding of ourselves and our place in the universe? The answers may be as profound as the mysteries themselves, and the journey is far from over. The journey into the deep sea is not just a scientific adventure, it is a philosophical odyssey, one that compels us to confront the most fundamental questions about life, existence, and our place in the cosmos. As we peer into the abyss and encounter creatures that should not exist by the standards of our surface world, we are forced to reconsider what it means to be alive, to adapt, and to belong. The existence of life in the deep sea challenges the very definition of habitability. For centuries, scientists believed that life required sunlight, warmth, and a stable environment. The discovery of thriving communities around hydrothermal vents and cold seeps, places devoid of light, subject to crushing pressure, and bathed in toxic chemicals, has upended these assumptions. Life, it turns out, is not a fragile phenomenon, but a force of astonishing resilience and creativity. It can take root in the most unlikely places, forging new paths and inventing new solutions to the challenges of existence. This realization has profound implications for our search for life beyond Earth. If the deep sea can harbor creatures that feed on chemicals rather than sunlight, that glow in the darkness and withstand pressures that would crush a submarine, then the universe may be far more hospitable to life than we once imagined. The icy moons of the outer solar system, the subsurface oceans of distant exoplanets, and even the clouds of gas giants may all be potential homes for life, if only we have the imagination to look. But the lessons of the deep are not just about the possibility of alien life. They are also about the nature of life itself. The creatures of the abyss are not just survivors, they are innovators, each one a living experiment in the art of adaptation. Their bodies, behaviors, and biochemistries are testaments to the power of evolution, to the endless capacity of life to reinvent itself in response to new challenges. In their diversity, we see the fingerprints of time, chance, and necessity, woven together in patterns that are both beautiful and bewildering. The deep sea also invites us to reflect on our own place in the web of life. For all our technology and intelligence, we are newcomers in a world that has existed for billions of years. The creatures of the abyss have endured ice ages, mass extinctions, and the shifting of continents. Their resilience is a lesson in humility, a reminder that survival is not about dominance but about adaptation, cooperation, and persistence. There is a sense of kinship that comes from exploring the deep. As we discover new species and unravel the mysteries of their existence, we are reminded that we are not alone, not just in the sense of other intelligent beings, but in the sense of being part of a vast interconnected community of life. The boundaries between us and them begin to blur, and we see ourselves reflected in the eyes of a snailfish, the glow of a jellyfish, or the patience of a tube worm. The philosophical questions raised by the deep are as endless as the ocean itself. What is the value of a world we may never see? Do the creatures of the abyss have intrinsic worth, independent of their usefulness to us? Is the search for life a quest for knowledge, for connection, or for meaning? These are questions that science alone cannot answer, but that lie at the heart of our journey into the unknown. The deep sea also challenges us to confront the limits of our knowledge. For all our advances, the abyss remains a place of mystery. A reminder that the universe is not only stranger than we imagine, but stranger than we can imagine. Every new discovery is a humbling experience, a lesson in the power of curiosity and the necessity of wonder. Yet there is also a sense of hope. The resilience of deep-sea life, its capacity to adapt and endure, is a source of inspiration in a world facing unprecedented challenges. As we grapple with climate change, habitat loss, and the pressures of a growing human population, the lessons of the deep remind us that life is not easily extinguished. It persists, it adapts, and it finds a way. The journey into the deep is, in the end, a journey into ourselves. It is a search for understanding, for connection, and for meaning in a universe that is vast and mysterious. The creatures that dwell in the darkness are not just objects of study. They are fellow travelers, companions on the road of existence. Their stories are our stories, their struggles our struggles, their triumphs our triumphs. As we near the end of our exploration, we are left with more questions than answers. But perhaps that is the greatest gift of the deep, the invitation to keep searching, to keep wondering, and to keep dreaming. The abyss is not a place of endings, but of beginnings, a reminder that the greatest mysteries are those that remain unsolved. In the next section, we will bring together the threads of our journey, reflecting on the enduring mysteries of the deep and the ways in which they continue to shape our understanding of life, the universe, and ourselves. The story is not over, and the adventure continues. As our journey through the deep sea draws toward its conclusion, it becomes clear that the abyss is not just a place of scientific discovery, but a wellspring of enduring mystery. The more we learn, the more we realize how much remains unknown. The deep is a realm where certainty dissolves, where every answer opens a dozen new questions, and where the boundaries of knowledge are constantly being redrawn. The creatures we have encountered, anglerfish with their glowing lures, immortal jellyfish, xenophyophores, and Hadal snailfish are not just biological oddities. They are living reminders that life is a process of constant invention. Each adaptation, each survival strategy, is a response to the unique challenges of the deep. Some creatures have evolved to be nearly invisible, others to be luminous beacons in the darkness. Some live for centuries, others for only a fleeting moment. All are part of a tapestry that is as intricate as it is fragile. The mysteries of the deep are not limited to its inhabitants. The very landscape of the abyss is a source of wonder. The trenches, ridges, and seamounts that shape the seafloor are the result of forces that operate on timescales far beyond human comprehension. Earthquakes, volcanic eruptions, and the slow drift of tectonic plates create a world in perpetual motion. A world where change is the only constant. The hydrothermal vents and cold seeps that dot the ocean floor are windows into the planet's inner workings. Places where the chemistry of life and the chemistry of the earth are inextricably linked. Yet, for all its dynamism, the deep sea is also a place of remarkable stability. Some regions have remained unchanged for millions of years, their ecosystems evolving in isolation, untouched by the upheavals of the surface world. In these ancient refuges, life has followed its own path, producing forms and behaviors that are found nowhere else. The discovery of these unique communities is a reminder that the deep is not just a frontier. It is a living archive, a record of the planet's history and the endless possibilities of evolution. The enduring mysteries of the deep are a challenge and an invitation. They challenge us to think beyond the limits of our experience, to imagine worlds and ways of life that are utterly foreign. They invite us to explore, to question, and to wonder. The abyss is a place where humility and curiosity go hand in hand, where the pursuit of knowledge is tempered by the recognition of how much we do not know. One of the most profound mysteries is the question of origins. How did life begin in the darkness of the deep? Did it arise around hydrothermal vents in the chemical cauldrons of the early ocean, or did it come from elsewhere, seeded by comets or meteorites in the distant past? The answers to these questions are still elusive, but the clues are all around us. In the genes of deep-sea microbes, in the chemistry of vent fluids, in the fossils buried in the sediments of the abyss. Another enduring mystery is the question of connection. How are the creatures of the deep linked to the rest of the planet? What role do they play in the cycling of nutrients, the regulation of climate, the maintenance of biodiversity? The deep sea is not an isolated world, but a vital part of the Earth system. Its health and resilience are inseparable from our own. And then there is the greatest mystery of all, the question of life beyond Earth. The lessons of the deep have transformed our understanding of habitability, showing us that life can exist in places we once thought impossible. The search for life on other worlds is in many ways a continuation of our journey into the abyss, a search for connection, for kinship, for a sense of belonging in a universe that is vast and mysterious. The enduring mysteries of the deep are not obstacles to be overcome, but gifts to be cherished. They remind us that the world is not finished, that there are still frontiers to explore and wonders to discover. They inspire us to keep searching, to keep asking questions, and to keep dreaming. As we reflect on our journey, we are left with a sense of awe and gratitude. The deep sea is a place of beauty and strangeness, of resilience and fragility, of knowledge and mystery. It is a place that challenges us to be better scientists, better stewards, and better storytellers. It is a place that reminds us of the power of curiosity, the necessity of humility, and the enduring value of wonder. In the next section, we will look to the horizon, considering the legacy of deep-sea exploration and the responsibilities that come with knowledge. What will we do with what we have learned? How will we protect the wonders of the abyss for future generations? The story of the deep is not just about discovery. It is about the choices we make and the future we create. As we stand at the threshold of the unknown, the legacy of deep-sea exploration is being written not only in the pages of scientific journals, but in the choices we make as a global community. The wonders we have uncovered in the abyss are both a triumph of human curiosity and a call to responsibility. The deep sea, once a distant and untouchable realm, is now within our reach, and with that reach comes the power to protect or to destroy. The knowledge we have gained from the deep is a double-edged sword. On one hand, it has revealed the astonishing resilience and adaptability of life, the intricate connections that bind the ocean to the rest of the planet, and the potential for discovery that still lies ahead. On the other, it has exposed the vulnerability of these ecosystems to human activity. The scars of trawling, mining, and pollution are already visible in some of the most remote corners of the ocean. The creatures of the deep, so perfectly adapted to stability and isolation, are often ill-equipped to cope with rapid change. The responsibility to protect the deep sea is not just a matter of ethics, it is a matter of survival. The health of the abyss is inseparable from the health of the planet. The deep sea regulates climate, recycles nutrients, and supports biodiversity in ways we are only beginning to understand. Its loss would be a loss not just for science, but for humanity as a whole. Conservation of the deep sea requires a new way of thinking, one that recognizes the value of what we cannot see, and the importance of what we do not yet know. It means creating marine protected areas that encompass the full range of deep-sea habitats, from hydrothermal vents to abyssal plains to hadal trenches. It means regulating activities like mining and fishing to ensure that they do not irreparably damage fragile ecosystems. It means investing in research and monitoring so that we can detect and respond to changes before they become crises. But conservation is not just the work of governments and scientists. It is a collective endeavor, one that requires the engagement of all people. The stories of the deep must be shared, the wonders of the abyss made accessible to everyone. Education, outreach, and citizen science can turn curiosity into action, transforming awe into stewardship. The deep sea belongs to all of us, and its future will be shaped by the choices we make together. The legacy of deep-sea exploration is also a legacy of hope. The resilience of deep-sea life, its capacity to adapt and endure, is a source of inspiration in a world facing unprecedented challenges. The lessons of the abyss, of patience, of innovation, of interconnectedness are lessons that can guide us as we navigate the uncertainties of the future. The creatures that dwell in the darkness are not just survivors. They are teachers, showing us that life is possible even in the most unlikely places. As we look to the horizon, we must ask ourselves, what kind of ancestors do we want to be? Will we be remembered as the generation that unlocked the secrets of the deep, only to squander its treasures? Or will we be the stewards who recognize the value of the unknown, who protected the wonders of the abyss for those yet to come? The answer lies in the choices we make today. The future of the deep sea is unwritten. It is a story that will be shaped by discovery, by innovation, and by the willingness to act with wisdom and compassion. The abyss is a place of mystery, but it is also a place of possibility. Its creatures, its landscapes, and its secrets are gifts. Gifts that come with the responsibility to cherish and protect. As we prepare to surface from our journey, we are left with a sense of both humility and empowerment. The deep sea has shown us that the world is larger, stranger, and more beautiful than we ever imagined. It has reminded us that knowledge is not an end but a beginning, a starting point for action, for reflection, and for hope. In the final section, we will bring our journey full circle, returning to the question that has guided us from the start. Are we alone? The answer, as we have seen, is more complex and more wondrous than we could have dreamed. The deep sea, with its impossible creatures and enduring mysteries, offers a vision of life that is at once humbling and exhilarating. The story is not over, and the adventure continues for us, for the ocean, and for the generations yet to come. As we rise from the depths, leaving behind the silent cathedrals of the abyss and the flickering lights of bioluminescent life, we return to the question that has echoed through every chapter of our journey. Are we alone? The answer, shaped by the wonders and mysteries of the deep sea, is both simple and profound. In the darkness beneath the waves, we have found a world teeming with life. Life that should not exist by the standards of our surface world, yet does. Life that is resilient, inventive, and endlessly surprising. In the deep, we are not alone. We are surrounded by fellow travelers, each one a testament to the power of adaptation and the boundless creativity of evolution. The creatures of the deep sea are more than just curiosities. They are living proof that the universe is capable of producing life in forms and places we never imagined. Their existence expands the boundaries of the possible, reminding us that the conditions for life are not as narrow as we once believed. If anglerfish can hunt in perpetual darkness, if tube worms can thrive on the chemical energy of the earth, if immortal jellyfish can reset the clock of life, then what else might be possible on our planet and beyond? The deep sea is a mirror, reflecting both the strangeness of the universe and the ingenuity of life. It is a place where the improbable becomes real, where the impossible is routine. The lessons of the abyss are lessons in humility and wonder. They teach us that life is not a fragile accident, but a force that seeks out every niche, every opportunity, every crack in the armor of the impossible. They teach us that the search for life is not just a scientific quest, but a journey of the spirit, a search for connection, for meaning, for kinship in a universe that is vast and mysterious. In the deep, we have found answers to questions we did not know how to ask. We have discovered that the boundaries between us and them are not as clear as we once thought. The genetic threads that bind us to the creatures of the abyss are reminders of our shared origins, our common journey through the eons. The resilience of deep-sea life is a reflection of our own capacity to adapt, to endure, to hope. The beauty of the abyss is a reminder that the world is richer, stranger, and more beautiful than we can imagine. But the story of the deep is not just a story of discovery. It is a story of responsibility. The wonders we have found are fragile, vulnerable to the choices we make. The future of the deep sea and of all life on Earth depends on our willingness to act with wisdom, compassion, and foresight. The legacy of exploration is not just knowledge but stewardship. It is the recognition that the greatest treasures of the abyss are not the minerals we can extract, but the mysteries we can preserve. As we surface, blinking in the sunlight, we carry with us the lessons of the deep. We are reminded that the search for life is not over. There are still frontiers to explore, still questions to ask, still wonders to discover. The deep sea is a beginning, not an end. A starting point for new journeys, new dreams, new possibilities. Are we alone? In the deep, the answer is clear: we are not. We are part of a vast, interconnected web of life, a tapestry that stretches from the surface to the abyss, from the familiar to the unknown. The creatures that dwell in the darkness are our kin, our companions, our teachers. Their stories are our stories, their struggles our struggles, their triumphs our triumphs. And what of the universe beyond? The lessons of the deep sea give us reason to hope. If life can thrive in the most unlikely places on Earth, then perhaps it can thrive elsewhere as well. The search for life beyond our planet is a continuation of our journey into the abyss, a journey that asks us to imagine, to wonder, to believe in the possibility of connection across the vastness of space and time. The adventure does not end here. The deep sea will continue to surprise us, to challenge us, to inspire us. Its mysteries will draw new generations of explorers, scientists, artists, and dreamers. Its lessons will shape the way we see ourselves, our planet, and our place in the cosmos. The story of the deep is a story without end, a story of curiosity, resilience, and hope. As we close this chapter, let us remember that the greatest discoveries are not always the ones we set out to find. Sometimes the most profound answers come from the most unexpected places. Sometimes the journey itself is the answer. In the darkness of the deep, we have found light. In the silence of the abyss, we have heard the echoes of our own questions. In the creatures that should not exist, we have found proof that life is not only possible, but inevitable. So let us keep searching, keep wondering, keep dreaming. The deep sea is waiting, its secrets still hidden, its wonders still unfolding. The question, "Are we alone?" is not a question to be answered once and for all, but a question to be lived, a question that invites us to explore, to connect, to celebrate the miracle of life in all its forms. In the end, the deep sea reminds us that we are never truly alone. We are part of a living world, a world that is vast, mysterious, and full of possibility. The creatures of the abyss are our companions on the journey, their existence a promise that no matter how dark the night, life will find a way. The adventure continues and the story goes on.